Hello everyone, I'm John Furrier, host of theCUBE. We are live here at the NYSE. This is our Wall Street headquarters for NYSE. And of course, we got all the action in Silicon Valley, between Silicon Valley and Wall Street, all making it happen. Our next guest is David Liu. This is the CEO of Plus AI, building the driverless trucks, part of the city and theCUBE and NYSE Wired Robotics and AI series. David, thank you for coming on theCUBE. Appreciate you coming on. Thanks.
It's great to be here. Thank
So
you.
before we came on camera, we talked that we both had a little stint at Hewlett-Packard back in the day, kind of an OG techie in Silicon Valley. So great to see you in New York doing the rounds and getting the investor interest. I'm sure you're going to be very popular in the city event with investors. You're working on one of the hardest problems, autonomous driving with trucks. Take a minute to explain what you guys do, and then I want to jump into it.
Yeah, so we founded the company back in 2016, 9 years ago, working on utilizing AI technology to transform the transportation industry. I mean, nowadays people talk about physical AI, we've been working on for 9 years already. What we observed back then is the trend that the AI technology has matured over the years, and then computing power has gained tremendously over the last 30 years or so, to a point where we think that the AI will be able to bring these driving technology or these vehicles to be fully automated and to be driven with the software rather than human driving.
Well, first of all, congratulations for taking that leap years ago, because right now it's the perfect opportunity because the accelerations of product cycles on one chips is significant. Just 2 weeks ago, we were there immersed in Nvidia GTC, and they have to lay out their architecture now over multiple years because it's generational, kind of a flywheel kicking in. It reminds me of the PC era when you started to see that the performance continue to increase. At the same time, supply chain, they got to get that locked in, and then the other side, they got an ecosystem, and they're featuring robotics on stage. So robotics, to me, is like the North Star of the AI world, because if you get there, you've made it, right? So, but it rhymes together, efficiency, scale, productivity, that's the AI story, but now on robotics, and this it's the same thing. Minimize complexity, efficiency. So where are you guys seeing the best AI bang for the buck right now, the best value in AI in your autonomous vehicles?
Yeah, so in the broader AI area, the last few years mostly focusing on AI application in the virtual world, where large language models, people utilizing to handle a lot of virtual tasks. But we're starting to see that AI is actually making a big entrance into the physical world. How do we utilize these intelligent systems to help us, drive the physical world to be more efficient? It is actually a problem people have been focusing on working on for the last 50 years. Autonomous driving is really not that new. Back in the 70s, that's when we first had some of these autonomous driving system, the first generation of it. But what's different between now and then is just the algorithm side. On the computing side, it's just think about it. On the computing power side, we're about 1 million times faster compared to 1970s, right? So those tremendous advancements made it possible for us to start utilizing these technologies to control the physical world.
And consumers can see ChatGPT on one side, but on the self-driving autonomous side, you see Tesla, you see Waymo, robo-taxis are here, already happening, trucks, natural. You tell us about your products, what's shipping, where are you in the status of the product, because you are autonomous trucks, not like the driver assisted, you're fully autonomous. Right?
Yeah.
All right, so where are you in the progress? Can you share some data?
Yeah, so we work with some of the largest truck manufacturers in the world together on enabling these driverless trucks. So one of our partners, for instance, is Volkswagen Traton Group, which covers 3 of the largest brands in the world, including Scania in Sweden, MAN in Germany, and then Navistar International in the US. What we're doing with them is start to do these commercial pilots here in the US, in Texas, and then in Europe, in Sweden. We're doing these driverless, autonomous L4 pilots with, starting with these OEMs to start hauling goods on public roads.
So take me through the challenges. I mean, obviously there's already complexity going through my mind around, okay, just to make the system work. So you got the trucks, like a car. A lot going on technically, computer vision, algorithms, compute power. It's a supercomputer on wheels, basically. But regulations, safety must be a huge concern. Can you share and scope the kind of complexity around what you have to navigate through to get the regulations approved, the safety, feeling good, and the tech?
Right. So, it is a safety-first industry, transportation, because we're on public roads and with all kinds of vehicles and other objects and pedestrians in some cases around us. So safety is always the top thing and top concern. And then we're working with regulators on how do we regulate these trucks with no drivers in them. We have lots of regulation around how a driver is supposed to drive a vehicle. And on these virtual drivers, right, there needs to be rules in place, and there needs to be plan in place. What if your vehicle gets into some kind of a trouble, right? How do you deal with that? So there are regulatory rules around these, these virtual drivers. Now, what's been very encouraging is majority of the United States, like 48 out of the 50 states, already have regulation in place to regulate these driverless trucks. So in terms of regulatory support, we're able to operate driverless trucks on most of the roads. And similar situation in Europe, majority of the, especially the Western European countries, you can operate a driverless truck today. So it's really about how do we work with the regulators together to kind of start this industry.
And where are you now? Where are you operating now in your test beds or pilots?
So our pilots in the States is in Texas. It's really starting with the San Antonio, Dallas, and Houston triangle. So a lot of our testing on pilots are going on there. And then in Europe, we're doing that in Sweden.
Yeah, flat roads, wide, not Boston.
So if you look at the heavy trucking industry, majority of the traffic is actually on highway, divided highways, right? So from an operating design domain point of view, it is a sort of a more heavily regulated testing environment.
And well known too, a little bit more data clarity. I think about like drivers. I've driven my car, so I'll use my car driving experience. The drivers in Boston are crazy. The drivers in California can be crazy. New York, New York taxis. So you get the humans are the problem, right? So yeah, they're a different kind of crazy. I use that in quotes because there's sometimes unexpected things happen. In Boston, you can tell that it's cultural. Kind of behavior. I'm sure in overseas I've heard other stories of other areas. So there's norms, and people kind of adjust to kind of like being loose with the law. How does AI factor in all that? Is that synthetic data? You guys do digital twins. How do you factor in for those unknown kind of random things? Synthetic data is popular in factories. Are you guys taking a similar approach?
Yeah, so we take both real world data and then we also take simulation data, right, synthetic data. So the thing about AI is it's data driven, right? It learns from the real world experience and then it can infer from that, right? So it not only can repeat what they observe in the real world, but it can also cover unexpected situations. The more data you get, the more intelligent the system becomes.
I got to ask you, what are you most excited about right now? Because this is one of those times where you guys working hard, you get the prototypes, engineering is off the charts. You got to do a lot of, industrial, there's also the software, hardware. Hardware and software seem to be the magic combination right now. And I mean that in the most hardware enabling dynamic software, upgrades, new integrations, whether it's AI, other AI. What's it like right now for you? What are you most excited about?
Yeah, I think the most exciting thing about what we work on is the sheer impact of what we'll be able to create, right? So 70% of all goods consumed and used by us are transported by large, heavy trucks. So there are a couple million of these heavy trucks in the United States. It's a $2 trillion market worldwide. And we also have a huge driver shortage. Like a lot of containers and goods that we need to move today are not basically getting delayed, or the shipping cost is high. So we're solving a big problem for our economy. So that's on the impact side. On the solution side, first time in many decades, we're able to finally solve this problem. And this will be the biggest invention since the diesel engine that's created in the transportation industry.
I mean, I just think about the safety. Human error probably accounts for a lot more accidents and safety issues than what an autonomous vehicle or truck could have. Do you guys look at studies like that? Like, is there data around? Because everyone's going, oh, no driver, something could happen. Well, what's happening with drivers? So I'm wondering if you have any perspective on the with a human in the driver's seat and without.
Yeah, so truck driving happened to be the one of the top 5 most dangerous job in the U.S. So accidents is one of the road accident. It's very, very dangerous for people, especially for the drivers. So we're solving a really acute problem here. Machines. The AI drivers. They're 24/7. They observe the road on a millisecond basis, right? So they always take in the latest information. They never get tired. They never get distracted. So we have data to show that our system is safer than an average human driver.
It's literally like driver's training. It's like when you have the instructor next to you, it's like, watch the road, I mean, they're watching the road. What's about the tech? Let's talk about the technology. What's going on in the vehicle? Can you share under the hood, so to speak, what's going on? What's the core technology? What's going on?
Yeah. So our technology, our product is this thing called the virtual driver. It's an AI system that sits on a high power compute system. It's local edge compute on the truck, right? So we have sensors installed around the truck with cameras, radars, and lidars. They take in data in real time, and they feed that data to the compute and into our core AI engine. So our AI would do the inference and make decisions on spot in the trucks. They make a decision, at perhaps like 20 hertz. So every second they make 20 decisions, right? So at that frequency, we make decisions about what's the safest driving command at the moment, given the surrounding situation, given the goal you're trying to achieve. Now, that AI driver, so that virtual driver, is trained in the cloud. So we take in the data that's being observed through our entire fleet, and then we use that data to train our AI, the core driver, on the regular basis, and then we deploy those virtual driver to the trucks.
I mean, just the notion of real time has been kind of overused, but sometimes misconstrued. Near real time isn't real time. You can't be driving a car and be near real time. I mean, you need really, really fast response. How was that solution put together on the hardware and software side? Are you putting this system together yourself? Is it engineered, purpose-built by your engineers, or is it a little bit of Nvidia? Is it a combination of a clustered system? I mean, it's basically a supercomputer to get that kind of response.
Yeah, so we focus on providing a software solution. We construct all the AI software on top of the hardware platform. And then we work with the entire ecosystem to build out the system. So for instance, our hardware platform is Nvidia based, so we're a close partner with Nvidia. In fact, recently we announced a couple of big collaboration partnership with Nvidia. We're one of the earliest user of their Thor platform, and we're one of the first user of the Cosmo platform. So on the sensor side, we also work with the leading sensor providers on lidars and cameras and radars. We use best of breeds that the entire industry can provide.
Yeah, I mean,
and then on the truck side, that's also a key, because you can make all the decisions you need, but you need a truck, a safe and redundant trucking platform to actually execute on your commands. And on that, we work with 3 of the largest global OEMs to deliver these redundant and reliable trucking platform. So again, includes
they're engineered trucks.
Yeah, these are
from scratch.
Purpose-built trucks engineered from scratch for the driverless trucking solution.
On the Nvidia piece, obviously I mentioned Jensen giving that roadmap, and obviously you must have loved his keynote because all he talked about was physical AI. I mean, this is as physical AI as you're going to get. How deep with Nvidia? Talk about the Nvidia relationship, because they're doing some pretty amazing work. What they're doing with digital twins. Obviously they have a perspective. Jensen Huang, he's the only CEO, I cover all the top events and CEOs. He's the only CEO that I've heard say the word computer science 3 times on the stage. He really, and he emphasizes intentionally, this is computer science, but it's also kind of industrial too. It's hardware and software, but the way he looks at it, it's software. this AI, physical AI world, you are the use case right now in production. How is that related with Nvidia? Because it's almost mind-boggling that you don't make any hardware.
Yeah. So Nvidia made a major bet in the automotive world for many, many years. We are one of their earliest partners. Back in 2018, when Jensen did his JTC keynote speech, he announced our partnership together. So they've been pushing along, trying to provide more edge compute, to utilize to put the solution like ours onto the vehicles. Only with that kind of enabling technology, we're able to execute on our AI software.
Yeah, and the chips he's showing and the systems that they have, Spectrum X on Ethernet, they got the InfiniBand obviously, interconnects. What's around the chips matter too, so I'm sure you pay a lot of attention to that piece of it too. You watch their roadmap pretty carefully?
Yes, we do. So we are, our roadmap is really walking step by step along with theirs as well. So they focus more on the hardware development side, and we focus more on the software development side.
It's interesting, I can't help but think, first of all, I know automotive, financial services are two hot areas for them. Obviously healthcare, pharma, this is where the big systems can deliver the real great value. You're in one of them. When I think about what you were just talking about, the first thing that jumps in my head was not to go in a rabbit hole here, but where do you store all the data on the car? So like all the so the storage vendors are selling more storage because there's more data, more synthetic data. So you mentioned the cloud. So talk about the relationship between the truck and the cloud, because you got to have some storage, primary storage on the truck. What's the storage look like? And again, I love their MV cache. I love what they're doing at Dynamo. That's going to make things better. I'm going to see that translating to the car. But where's that primary storage tier? Is it SSDs as capacity tier? How do you think about storage?
So on the edge side, on each truck, the data is of big volume but not huge. Those are basically stored as on SSD disks. And we don't store all data. We store interesting data locally on those trucks. And then we have a fleet of these vehicles, right? And then they all upload the interesting data to the cloud. And there the data volume is counted in petabytes, right? So order of magnitude greater than what's on the truck.
You're not talking petabytes or exabytes. You're talking about smaller sizes. So your upload constraints not a problem.
Yeah, upload constraint on the truck side is really on the terabyte basis, right? And but once it gets in the cloud, then you have petabyte, exabyte, and all that.
I always thought that Tesla would have there'd be uploading stations, just like there's like charging stations. But because you think computer vision, there's massive data that's coming in from the cameras. So you're selectively masking out that data acquisition from a storage standpoint with software?
So that's down selecting or the filtering of data is crucial, right? Because if you collect all of that data and try to upload all of that to the cloud, then you're going to crash your data center pretty quickly. So it is a piece of our core technology to figure out what is the interesting data that you need to store, and then we can utilize that interesting data to train our AI engine to make it smarter.
So David, I have to ask you, on the automotive industry, how would you peg the progress of other companies, other automotive, commercial or truck manufacturers? Where are people in the progression of their journey, and how do you relate to their progress?
So the interesting thing about autonomous driving is that this industry has been in existence for not 10 years, not 20 years, for almost 50 years. So that's one first interesting fact.
That's new information to me.
The second interesting factor is that this industry tends to reinvent itself every 5 years. So 5 years ago, if you look at it, none of this large language model thing even exists. People don't talk about generative AI. When people talk about AI, it's more like convolutional neural networks. Those are small models, right? But since 3 years ago or 4 years ago, people start these models tend to grow larger and larger and larger. Now with ChatGPT, famous ChatGPT, now everybody understand that when model size grow to a certain size or over a certain size, it accumulates this intelligent behavior, emergent behavior that people weren't expecting.
Yeah.
So that basically, if you look at the current trend or the trend we're on, this another wave of technological innovation it didn't exist 5 years ago. So
And the reasoning and the reinforced learning is coming. What's going to be the core technology in the truck, and what's the core technology in the cloud that's coming next?
yeah, so I think this is what Jensen talks about physical AI. It's a combination of large language model, vision language model, larger models, and then a key thing there is verifiable large models, right? You have to be able to explain why your large model is making certain decisions.
It's like a compiler for the compiler.
Yeah.
Because we want the data to be good. All right, so I want to ask about what you just said about autonomy's been around for 30 years. In what form, or was the science around for 30 years? Yeah. Was there actual deployments? Because I haven't seen any driverless cars or trucks, but so what do you mean by it's been around for a while? The theory, the
theory and the practice. So the first autonomous-driven vehicle was created by DARPA back in the 1970s. And it's actually a neural net-driven technology. So talk about and then that moved down to sort of the late 90s and early 2000s. Now people go into more of a robotics approach. Yeah. Right. So
but no production workloads.
No production.
But definitely the capability. It's like AI. When in the 80s, when I got my CS degree, we talk about AI, neural networks, but no one could find compute. Right. So that was a problem. Like, where are you going to find the computing power? And all the high-performance computing was like time sharing. Yeah. It was horrible.
So if you look at where we are today, compared to 50 years ago, on the algorithm side, these neural networks, went from like baby networks now to these gigantic large networks, right? On the compute side, again, it's almost 1 million times more powerful compute system compared to 1970s. On your cell phone, you have more compute than the entire Apollo program, right? So that's why we're able to get to where we are today.
Talk about the fleet intelligence. Obviously, you're going to have fleets of trucks, the vision there around how you're going to use this kind of singularity brain, because the trend is you're uploading, the cloud's going to be distributed computing, you got the optimized purpose-built trucks, you got the brain inside the truck, it's doing its job, it's driving. The data is going to be very valuable. How do you think about the data in the collective sense? Because you're going to get primary data now, not just synthetic data. So at some point, you start bringing in this by the truckload, pun intended, more data. So how do you think about the collective data from the fleet?
Yeah, we like to think about the entire transportation network as one gigantic virtual factory, right? Nowadays, if you walk into a modern factory, you don't see many people walk around the factory floor. These are all automated with robots and this and that. Now the transportation network we have today, nationwide, you can think of this as one gigantic factory. If you take a slightly longer view, think about 30 or 50 years later, you can envision a system that's fully automated with all the individual transportation vehicle being just a member of this entire fleet network.
You think about where we live in California. We're in the Bay Area. When someone says, "Hey, let's drive to LA," everyone's like, "Whoa, that's a long drive. It's dangerous." Anyone's been on the 5 going to LA, it's like trucks are going a zillion miles an hour. Trucks are people are zigging. At some points, we've been speculating that with robotics, it's safer. Imagine jumping into an autonomous vehicle and just getting to LA.
Yeah, especially I drive the I-5 a lot of times, right? If you look at the right lane, it's basically a conveyor belt, right? It's with lines of trucks just driving on that all day long, right? Wouldn't it be great if we can automate that? Like it'll make the road so much safer.
Take a new expression to stay in your lane. David, it's been great. So let's talk about as CEO. First of all, I love the conversation. I'd love going another hour. I know you're very busy with the event tonight with the city and all the investors and whatnot. I'm sure you got tons of action going on there. Talk about the business. Headcount. What's the status of the company relative to your milestones? What are some data you can share on KPIs? What are you focusing on? What are you optimizing for? What's on your agenda?
Yeah. So we're tech centric. We're R&D centric. Majority of our development people are Silicon Valley based. We're not far from Nvidia and Intel and all those companies. We have a small office in Munich, in Germany, to serve our European clients.
And a lot of car makers out there.
Yes,
close to the supply chain.
So we work on sort of the AI technology, the data engine. So We
Yeah.
like to think ourselves as all data engineers. We manipulate data, we make models, and then we produce software.
Well, take a minute to put a plug in for who you're hiring. I'm sure as challenging and how big, cool the opportunity you have. I'm sure there's a great appetite for the engineers who want to always complain, I want to work for a company that's solving hard problems. Well, I think you're doing that.
Yeah.
Who are you looking for? What kind of talent are you hiring? Take a minute to explain some of the things you're looking for.
Yeah. If you want to build the most awesome next generation robot that can drive a vehicle better than a human, you should work for us.
Great to have you on. Thanks for coming on. As they say, keep on trucking.
Thank you.
I'm John Furrier here at the NYSE, bringing down all the robotics and AI integration and the innovation around this next generation environment we're going to be moving into. Again, efficiencies, ease of use, productivity, and all kind of rhyming together with AI and robotics all coming together. Of course, we get bringing you all the live streaming here from Wall Street. I'm John Furrier. Thanks for watching.